Today we are continuing on modeling math problems, and we're going to look first of all at percentage and mixture problems. They work very similarly, so I've kind of lumped them together as a group. First question, Maggie invested $1,000. Part of that $1,000 was at a rate of 8% per annum. Per annum just means per year, and the rest at 9% per year. After 1 year, her total interest from these investments was $84. So interest really is the extra money that you earn on top of the original investment. So if I were to calculate 8% of $1,000, because perhaps I invested all $1,000 at 8%, I would multiply 1,000 by 0.08, which is the decimal form of 8%. And that would tell me how much money I earned as extra money. That would be my interest. As opposed to the total amount, which would be my original 1,000 plus the extra 84 or whatever the money was as interest. All right, and then the question's asking, how much did she invest at each rate? So for a let statement, I'd be letting perhaps E represent the amount invested at 8% and perhaps N for 9%, or I could just use an X and a Y. In any case, I need to do my let statements. So I'm going to type those in here. Let's see if I can get this to come up. I'm going to let X represent the amount invested at 8. And then I have to find the percent button. There it is, percent. And then I can let Y represent the amount of money invested at 9%. Now, some people would ask, well, why wouldn't you just invest it all at the higher percent? Perhaps before the investment was actually made, she didn't know ahead of time that that investment was going to be making 8% and the other one was going to make 9%. Perhaps it's something that you can't predict ahead of time. It's based on stocks or something like that. All right, so we need our equations. We know all together the two amounts have to add up to be $1,000. So I could say that X, let me just pick my pen here, X plus, so the amount at 8%, plus the amount at 9%, they have to add together to be $1,000. And then the interest amount. The interest is the actual percentage. So if I did 8% of the amount invested at 8%, or the X, 8% is 0.08 as a decimal number, times the amount that was invested at that would give me the interest earned, plus, and then the other percentage was 9%, 0.09, times the amount it was invested, the amount of money that was invested at that rate, and that total amount of interest was $84. So the percent times the amount gives you the amount of interest the investment had. Okay, and then you can put that into decimals and solve that. Okay, and once you put that into decimals, I was able to get an intersection point at 600, 400. And remember, that's the X and the Y. So I know that X is the amount invested at 8%. So $600 was invested at 8%, and then $400 was invested at the 9% rate. So we want a therefore statement. So therefore, $600 was invested at 8%. And $400 was invested at 9%. Okay, next question. Millhouse needs to make 500 milliliters of a 28% alcohol solution for an experiment. All right, and then he has a 40% solution and a 20% solution. So he's got to add a bit of this one and a bit of that one. So overall, the overall alcohol percentage will be 28%. How many milliliters of each type should he use? So my let statements hinge on this right here. I'm going to let X represent the number of milliliters of 40% solution, and then I could let Y represent the number of milliliters of the 20% solution. So go ahead and you can write that down. Okay, and now what we need to do is come up with our equations. Altogether, the total number of milliliters that I need is 500. So 500 is my total number of milliliters. So if I took X, which is the number of milliliters of the 40% solution, and add to it the Y, which is the number of milliliters of 20% solution, they have to add together to be 500 milliliters. And then we need this percentage. Overall, I need the X amount is the 40% solution. So I would have 40% of the X being alcohol, plus I have 20% of solution Y being alcohol, and that overall I want 28% of my total milliliters. So 0.28 is 28% of, and this time I know the milliliters instead of X and Y, I'm using the actual total. So just sort of as a key understanding here, we really have like the percent times the volume plus the percent times the volume equals the percent times the total volume. So just keep that in mind. That's going to work for mixture problems as well. Okay, and then you can put that into Desmos and solve the system. Okay, hopefully you've put that into Desmos. I did that and I got an answer here. Let me change back to my pen because I think I actually have my marker out. Change it back to the pen. I have, let's see, an intersection point of 200, 300, which then means I would need 200 milliliters of the 40% solution and 300 milliliters of the 20% solution. And I should write a therefore statement for that. Okay, moving on to the next question. It's a nice little mixture problem here. Apu decided to mix cashews and pecans to get 50 kilograms of nuts that sells for $10.08 a kilogram. So we've got a total number of kilograms and we've got a price per kilogram. If cashews normally sell for $9.60 per kilogram and pecans are selling for $10.80 per kilogram, how many kilograms of each type did he use? So how many kilograms is what we need to find, so that tells me what my let statements are going to be, and I'm going to type those in. Okay, and now we need to develop the two equations. So if you want a chance to do that, put me on pause, try it, and then I will explain. Okay, so altogether we have a total of 50 kilograms of nuts. So that means if I took the number of kilograms of cashews plus the number of kilograms of pecans, they have to equal up to be the total number of kilograms, which is 50. So that one's straightforward. And then we've got our prices happening. So cashews, which is my X, are selling for $9.60 for every kilogram. So if X is the number of kilograms, the price of the cashews should be 9.6 times the mass of the kilograms. So we should, the mass of the cashews. So 9.6 is our price per kilogram times the number of kilograms, and I don't need that bracket, times the number of kilograms of cashews, which is X. To that, we're going to add the pecans, which sell for $10.80 per kilogram, and there's Y kilograms for that one, and that has to give us the total, and our total is selling for $10.08 per kilogram, and we have a total of 50 kilograms. So again, you can put that into Desmos, find your solution, and write your therefore statement. Again, put me on pause, try that, see what you can come up with. Okay, when I did my solution, I came up with a ordered pair of 30, 20. That means we would need 30 kilograms of cashews and 20 kilograms of pecans.